Final part of corrosion is just crevice and pitting corrosion. Essentially, it's the same mechanism, but one of them happens in a crevice, one of them happens in a pit. Okay, so I've put the word aluminium here because crevice corrosion is one of the big reasons in aircraft skin failure. When you go up in the air, the temperature 15,000 feet, 20,000 feet up in the air is sub-zero. When you return back down to ground level, condensation happens onto the cold metal surface, and the condensation runs in the gap between two sheets of aluminium and stays there. When you go through a rainstorm, obviously, water gets into that crevice. So you've got a crevice with an aqueous environment. And of course, because it's a crevice, it can't evaporate easily and the water stays in there once it's there. So, crevice corrosion in aluminium is the issue. One of the big issues, the reason why they actually go and change the entire skin of an aircraft every so many thousand flying hours. The other one is fatigue cracking, also affects aluminium. But they're the two reasons why they have to change the skin regularly. Crevice corrosion is happening inside the crevice. You cannot see it from outside. It just happens, and then the first you know about it is when it's fallen apart and falling off. So, what actually happens, if I've got an aqueous environment, I've got chlorine, salt water from salt air, I've got oxygen dissolved in water, and then I've got metal. It starts out, the metal just uniformly corrodes. But then what happens is, inside the crevice, the oxygen cannot really migrate quickly and easily into it. So I end up with a whole stack of positive metal ions dissolving and moving to the interface back out here. So I end up with a positive and a negative end that then tends to accelerate. So I end up with cathodes don't corrode, anodes corrode. It just corrodes from the inside out. That's crevice corrosion. Could be the skin of an aircraft. Pitting corrosion is if I've got a passive oxide layer, one that doesn't react, but if I get a scratch in it, or if I get on the bottom of a tank, I get a little bit of dirt and I form a tiny crevice. That accelerates through the oxide layer and makes a little hole. Now in here, pitting generally occurs in stagnant water, stagnant conditions. Chlorine is heavier and it sinks to the bottom. Chlorine will sink into the pit and stay there. And then just locally accelerate through and you just get a literal pinhole. Like if somebody's got a pin and stuck it through a bit of steel, 1 millimetre thick, 2 millimetres thick. So you just get this pinhole, just straight through a pit. Pitting corrosion is what happens there. Same mechanism, just a different situation, different set of circumstances.